Right now, the smartest engineering teams in the world are quietly abandoning the chat interface, while the rest of the internet is throwing tantrums over whether Claude Fable 5 is 2 percentage points smarter on a benchmark than GPT-5, or whether Gemini handles a multimodal prompt slightly faster. They're asking the completely wrong question. They're asking, which model is smarter? The real question, the one that determines who survives the next 5 years of enterprise automation, is this. How do you make Claude work a 24-hour shift without needing a human to babysit it? Think about how you use Claude today. You open a tab, you type a brilliant prompt, you get a brilliant answer, you copy-paste it, you close the tab. That isn't a strategy. That's using a multi-billion-dollar neural network like a lawn ornament. It's the equivalent of hiring a world-class systems engineer for exactly 30 seconds, asking them one question, and firing them on the spot. The moment you close that browser tab, the intelligence vanishes. Claude doesn't remember what it did yesterday. It doesn't wake up tomorrow and check your inbox. It doesn't monitor your competitors while you sleep. It doesn't take ownership of an outcome. It just sits there, completely static, waiting for another human to feed it another prompt. We've trapped frontier intelligence inside a state of perpetual amnesia. The real revolution isn't the next LLM upgrade. The real revolution is the runtime layer that wraps around it. Frameworks like Hermes that convert Claude from a conversational chatbot into a persistent, autonomous digital employee. Today, we are stripping away the AI wrapper marketing fluff. We are going to look at the actual systems architecture required to transition from generative chat to autonomous execution. If you want to build a system that actually works instead of just talking, you have to separate the brain from the body. In an enterprise architecture, Claude is just the reasoning engine. It's the CPU. But a CPU without an operating system, a hard drive, and a network card is just a useless piece of silicon. The Agentic runtime is that operating system. Let's look at the blueprint of how this functions under the hood. At the core, the framework splits execution into two synchronized tracks. The memory layer and the planning loop, with Claude acting as the central intelligence driving both. When you deploy a digital employee, the first thing you have to solve is memory. Traditional software relies on databases. Human employees rely on experience. An agent needs both, split into two distinct layers. First, you have episodic memory. This tracks the immediate context of a running task. If Claude is analyzing a 500-page financial document, the episodic memory maintains its current position, local variables, and the active execution graph. Second, you have semantic memory. This is your long-term cross-session vector storage. When day one ends and the agent finishes an analysis, Claude doesn't delete its context. The system vectorizes its findings, its mistakes, and its open questions, and writes them back to a permanent data layer. When day two begins, the runtime automatically injects that historical context back into Claude's system prompt. The agent doesn't ask you, "What was I doing yesterday?" It reads its own logs, instantiates its previous state, and picks up exactly where it left off. That is the difference between an interactive conversation and an actual career. But reasoning and memory are still just thoughts. And in production, businesses don't pay for thoughts, they pay for actions. If you ask Claude in a standard chatbot window to monitor your competitors, it gives you a list of strategic suggestions. If you ask it inside an agentic framework, it builds a mission. But to execute that mission, Claude needs hands. Historically, this is where agents failed. Engineers spent weeks writing brittle custom API wrappers for every single tool they wanted the AI to use. If an API endpoint changed by a single character, the whole system collapsed. That era is over, thanks to the widespread adoption of MCP, the Model Context Protocol. Think of MCP as a universal USB port for artificial intelligence. Instead of hard-coding tools directly into the agent code, the runtime connects to independent MCP servers. These servers expose secure, standardized interfaces, like file systems, web browsers via Playwright, production databases, or communications APIs. When the agent executes, Claude dynamically inspects the available tools connected to that universal port. It handles tool selection based on real-time reasoning, not rigid, pre-written code lines. Let's trace a live operational loop. The goal is competitive intelligence. Claude reasons. I need the latest pricing data from X company. It calls the Playwright server to launch a headless browser, navigate the site, and extract the data. But what happens if the website's layout changed overnight and the extraction fails? In a traditional automation script, you get a fatal exception error, the cron job dies, and your pipeline breaks. In an agentic runtime, the system enters a reflection loop. Claude catches its own execution error, analyzes the changed page structure, rewrites its extraction strategy on the fly, and retries the action. This isn't AGI, it's just operational resilience. And in the real world, resilience is worth a lot more than raw intelligence. Now, let's talk about the danger, because when you give Claude memory, tools, and the autonomy to loop until a task is done, you've built something inherently volatile. If you leave an agent unconstrained, a simple logic flaw can create a runaway loop. It will call an API 10,000 times in 5 minutes, blow through your token budget, lock your production database, and get your IP blacklisted. An enterprise-grade agent workforce stack requires 3 absolute deterministic governance pillars. First, budget caps. This provides strict token and API cost control, acting as a mandatory hard stop on runaway execution loops before you wake up to a massive cloud bill. Second, human-in-the-loop gates. This enforces manual cryptographic validation for high-privilege actions. Claude should have the autonomy to research, draft, analyze, and stage code or communications. But the moment it needs to execute an action with real-world consequences, like sending an email to a client, modifying a database schema, or authorizing a financial transaction, the runtime freezes the state and pushes a verification request to a human manager. Third, structured logs. This guarantees full traceability and comprehensive audit trails, capturing every single state mutation in an unalterable record. When you look at this setup, you realize the economic model of enterprise software is fundamentally shifting. For the past 20 years, companies bought software via B2B SaaS seat licenses. You paid $50 a month per human user. In the agentic era, you aren't buying tools for your employees. You are allocating compute to deploy digital labor. Your cost metric shifts from software subscription fees to compute overhead versus task value. If it costs you $3 in compute tokens to have Claude flawlessly execute a deep dive competitive analysis that used to take an associate 6 hours to complete, the economic calculus is over. It's not even a debate. The corporate world is going to split into 2 camps very quickly. Camp A will keep looking for the next shiny chatbot UI. They will buy bloated AI add-ons for their existing software, get minimal productivity gains, and wonder why the tech didn't live up to the hype. Camp B will realize that frontier models have reached a structural tipping point. Claude, and the architectures surrounding it, possess enough cognitive endurance to manage complex, multi-step objectives over extended periods. They will stop looking for chatbots and start building agentic infrastructure. They won't be buying AI tools, they will be building AI workforces. The frameworks are open, the protocols are standardized, the hardware is scaling. The only variable left is how fast you build the harness around Claude. If you're ready to stop prompting and start engineering, the complete architectural breakdown and repository links to the runtime layers we discussed today are down in the description below. Build systems, not prompts. See you next time.